In the last episode, we saw one of the applications of determinant was to find the area of the triangle. So we had the area of a triangle with 3 given points, and we used this formula to find the area of the triangle, which is the absolute value, positive or negative, whatever we need to use, 1 by 2 multiplied by the determinant of this particular matrix, or using these 3 vertices, we formed a determinant. Now, another example is kind of a related one, and both should go together, but I'm putting a separate video, is given 3 points, and we have to prove, or we have to find out if all the 3 points are collinear or not, meaning that do they lie on the same line. If it's a triangle, it's going to be like this. You have A, B, and C. And let's say I split open from here and I form a straight line and I move this towards anti-clockwise, then it becomes A, B, and C here. In this case, there is no area. We just have the length of this line, but we don't have an area because it's no more a triangle and all these points are collinear. So let's say we have to find whether the points are either collinear or we have to test it using determinants. What does it mean is, in case these 3 points given are not forming a triangle and they are in a straight line, that means that the formula that we used earlier, the determinant of that, we don't have to worry about the plus or minus half, because we are just trying to find whether the points are collinear or not. We don't have to really find whether the area exists or not. What we need to do is, if we take the determinant of this, and based on the value of the determinant, we'll know whether the points are collinear or not. And what is the formula? If the value of the determinant, you construct the determinant in the same way. The first column is all about x values, the second column is all y values, and the third column is number 1. That stays the same. And you just don't use the plus or minus half over here. You just form this determinant 3 by 3. You compute the value of that by choosing any row, any column, the way we know how to find the determinant. And if this value equates to 0, that means the area does not exist, because all these 3 given points are collinear points. They are coming in the straight line. And just as a reference, non-collinear means they are not going to come in the straight line. They're going to, when you connect all of them, they form a particular shape. Whereas if they're collinear, there's only one shape, which is a line, and a line does not have an area. There is no area for a line. It just has a length. So if the determinant of a 3 by 3 matrix formed in this composition, based out of the 3 points given to you, is collinear, then the determinant is 0. Alternatively, if there are 3 points given to you and the determinant formed in this fashion is equal to 0, that means the 3 points are on the same line or collinear. That's what it means. So another small kind of problem where you might get an exam to prove whether it's collinear or not, and you can prove that. That's all on this, and we'll move on to the next episode.